So this is section 1.5, angular and linear velocity. This is the first part of the section, the first half of the section. The next part of the section we'll do next week, or our next class period. Section 1.5 is on angular and linear velocity. So to begin, we have to remember from geometry class the arc length formula. If we look at a circle of radius r, with a radius r and a central angle that measures theta degrees, the length of this arc here formed by these points here and here, this arc right here has a length of r, the radius, times the measure of the central angle. So let's look at the indicated arc length. Okay, in this example here we have a circle. The inscribed angle, the central angle measures 3 radians and the radius is 7 inches. So let's draw this. We could draw a circle if we want, but we don't really need to because we need the arc length formula. The arc length formula is L equals R times theta. Well, our radius is 7 inches and our angle measure is 3 radians. So 7 times 3 is equal to 21. And our units, since we're given the radius in inches, our length of that arc is going to be 21 inches. Okay? So that's how you find arc length for given the angle of the angle that you're given, the central angle, and the radius of the circle. All right. The next part is talking about angular displacement. All right. Sort of like if you have like a wheel, and say you want to look at how far it turns in one revolution or whatnot. That's sort of what we're doing here. So angular displacement is the angle theta a point is rotated on a circle. All right, so if we have a circle here, let me draw one for you quickly. All right, if we have a circle here, and say we have a point on that circle before it starts moving, and then it moves, say, over to this position here, the angular displacement is going to be this angle here that is formed from its initial starting position to its finished or ending position. Now it's important to know here that one rotation is equivalent to 2 pi radians. We've been using the radian unit this entire section, so it's important to know that. As I've stated before, there's many conversion factors in this chapter that you need to know. This is yet another conversion that you should know. Okay? So let's look at an example of angular displacement. All right, a tire makes a 2/3 revolution about its axis. Okay, so if we're looking at a certain tire, a tire is a circle. Let me draw that circle there. The point starts, we'll say on the ground right there. It makes a 2/3 revolution, so it revolves all the way around to here. Per se, that's about where 2/3 would be. Don't know why my pen started doing that, but we'll erase that real quick for us here. Let me get a bigger eraser there, and we'll erase that. But that, so that point revolves all the way 2/3 of the way, which is about right here. So we're looking at this angle right here. All right, and that angle can be found by multiplying 2/3 times 2 pi, and 2/3 times 2 pi is going to be 4 pi over 3. How we get that 2 pi is over 1, so we can multiply the numerator and denominator together. So we get 2 times 2 pi, which is 4 pi, and in the denominator is 3. And this unit here, 4 pi over 3, that's going to be an angle measure, and it's in terms of pi, so our unit is the radian unit of measurement. Okay? So that's sort of how you do this. So if it made, say, the tire made a 4/5 revolution, if it made, let me put that, a 4/5 revolution, what you would do is you would take 4/5 and multiply it by 2 pi, and you would get 8 pi over 5 radians. Okay? Then the last little bit is angular velocity. Angular velocity of a point on a revolving ray is the angular displacement per unit of time. The Greek letter omega here is what we use to represent angular velocity, and that's going to be theta divided by time. So it's going to be radians per second here. That's the unit that we use. Okay? That's going to be the unit that we can use, or radians per minute, or radians per hour. Whatever the unit is that we're given, we will use. So this right here is yet another useful formula. Alright, so example here, find the angular velocity in radians per second. Let's say a wheel turns at a rate of 35 radians per minute, or revolutions per minute. Alright, our angular displacement, omega, that's equal to theta divided by t. Alright, well, if we're doing 35 radians per minute, or revolutions per minute, right, that's going to be 35 revolutions per 1 minute. And we're going to have to do some form of conversion here. Alright, we want it, the angular velocity in radians per second. So we're going to have to multiply 35 over 1 by the conversion rate, that there are 2 pi radians per 1 revolution. And what we do is we can now eliminate or simplify the units, the revolutions. So now we have radians per minute. All right, well, we want it in seconds. So we have to do one more conversion here. And we have to multiply it by 1 minute over 60 seconds. Okay, so now we have the minutes units simplifying out. Okay, sort of like the customary conversions. So now we're left with radians per second. So we can go in the numerator, 35 times 2 pi. That's going to be 75 pi over, in the denominator, 1 times 1 times 60, which is 60, and that's, the unit is going to be radians, not 75, it's going to be 70. I was thinking a little odd here. 35 times 2 is 70. It's going to be 70 pi radians per second. And then we can simplify 70 pi radians, 70 pi over 60 radians to be 7 pi over 6 radians per second. And that's how you find angular velocities under a given unit of time and angular velocity, like radians per second or radians per minute. If it was radians per minute, we wouldn't even have had to have done that conversion factor. We could have just left it at these two here. We would have only have multiplied it by 2 pi over 1 radian per revolution. But because the initial prompt said to find the angular velocity in radians per second, we had to go ahead and multiply it by 1 minute, which is 60 seconds, and the minute would have to be in the numerator because minutes was in the denominator in the original problem, revolutions per minute. Okay, so that's the first little portion of this section here. The homework that you'll have is from the textbook, pages 26 through 27. The practice exercises, numbers 1 through 18. And in reality, you have an entire weekend to do these, so you have more than enough time to do these 18 problems based off of the examples that were done. If you have any questions, please send them through Remind or email, and I will do my best to get back to you. And we'll do a little bit of review of this on Monday when I see everybody. All right. Thank you for watching. Have a wonderful day.